Okay, this is Dr. Williamson, and I made a mistake on one of the problems, number 9 on the worksheet, and I chose this answer to the solution to the pH of a 0.22 molar NaF solution being 2.56, and the and I solved it like it was a hydrofluoric acid solution instead of sodium fluoride solution. So what I need to do is fix my error so you guys do it correctly. I'm sorry about that. A student came into my office hours and I went and solved it like it was hydrofluoric acid, not sodium fluoride. So let me put up this little video and show you guys the right way. All right, so let's take sodium fluoride. That's a salt. We put that in water and it's going to break up into sodium ion plus fluoride ion. Then then the sodium ion, we're doing our 3-step hydrolysis of a salt analysis. We react that or see if it'll react with water. And remember the little gimmick. We think of water as H plus, OH minus, and that's going to try and make sodium hydroxide, which is a strong base. We won't have any reaction from that. So sodium is a spectator ion. But when we react sodium fluoride with, when we put it in water, the fluoride will react with the water, right? And it will make the weak acid hydrofluoric acid plus hydroxide ion. This is what I should have done. And when I looked at it, just I mentally auto-corrected and thought of it as a sodium fluoride. I mean, as hydrofluoric acid, not sodium fluoride. So now we make a nice chart out of this, right? Okay. So now I CE. So it's going to start out initially 0.22 molar fluoride ion. Water is in large excess. This was initially 0 molarity. And this is initially 1.0 times 10 to the minus 7 molarity. We're going to call that approximately 0. Since we had no hydrofluoric acid to start with, the equilibrium, the reaction is going to have to shift this way to start with in order to go to equilibrium. So this is going to be minus X. This is going to be plus X. This is going to be plus X. So we're going to have 0.22 minus X. This will be X. And this will be X. We're going to have K is equal to HF OH minus over F minus. And what kind of K is this? Well, this water, excuse me, this fluoride ion is accepting a proton, H plus, from the water. So the F minus is acting like a base. So this is Kb. This is K base. And we're not given a value of K base. We are given Ka in the worksheet. Ka is, in the worksheet, it says it's 3.5 times 10 to the minus 5. I need Kb. Kb, I need a numerical value. That's going to be K water over Ka. K water is 1.0 times 10 to the minus 14. We're given Ka. So let me calculate that. 1 times 10 to the negative 14 divided by 3.5 to the negative 5. And that's going to give me, I'm not going to worry too much about sig figs right now, guys. Okay. Let's see here. Let me move this over a little bit. That's going to give me 2.9. Again, I'm not worried about sig figs for the purposes of this solving this problem. Times 10 to the minus 10. So this will be 2.9 times 10 to the minus 10. And when I plug that in, I'm going to get here x squared over x, excuse me, not x, but over 0.22 minus x. When I check, the x is small approximation works. So I'm going to end up with the hydroxide ion concentration is equal to x. How do I know? Hydroxide ion concentration is equal to x. I set up the table. And that's going to be equal to the square root of 0.22 times the value of Kb, which is that thing. Okay. So I'm going to take that, K 2.9 times 10 minus 10 times 0.22. Take the square root of that, and I'm going to get something like 7.9 times 10 to the, I think, minus 6 molarity. Then the pH will be equal to 14 minus the POH, and I take the logarithm of this minus log of that. That gives me a POH of 5.1. And so I get a pH of basically, let's see here, 8.90, which is the correct answer for this problem. Okay, guys, I apologize. I misread it when I read the problem. I thought it said 0.2 molar, 0.22 molar HF when I read it. And the student who came into my office hours, if he looks at the notes that I wrote down, I went and reread it again as 0.22 molar HF. And I did a mighty fine job of doing a great solution to the wrong problem. And therefore, I was wrong. Okay. So I hope this is better, guys. I apologize for the confusion that I caused, and I hope this helps. Okay, then. Bye.